we all got that glued in. So 3.48 intercepts of a graph. Who could tell me real quick, what is an intercept? Alex, what is an intercept?
When a line passes through another line.
When a line passes... Okay, when a line passes through another line on the graph. Where have we heard the word intercept outside of math? Anyone?
Interception.
Liana?
In sports.
In sports? What do you mean?
I don't know. I heard it once. I don't remember. Which
Okay, anyone know what Liana's talking about? Christian, what is she talking about?
Like when you intercept the ball, like in football, I think.
Okay, when you intercept the ball in football, what does that look like? What? Tackling? Close. That's okay. Judah, help us out. What does an interception look like in football?
When you throw it into open fields, and then the other team catches the ball.
Okay, so here's me.
Like a big Aaron.
Right, I got my ball.
outside linebacker. You didn't
Okay. Here's Judah. Right?
Judah.
Okay. Are we all looking or are we talking?
Yeah. We're good.
Okay. So here I am. I got the football. Here's Judah. He's getting ready for the pass. I'm going to launch this football straight across. Well, that's not a straight line, but you get the idea. I'm going to throw that football along that line so that Judah catches it, right? And then all of a sudden, here comes Christian. Okay? And he jumps right in the middle of the ball's path and he grabs it. Okay, so right when the ball's here, he grabs it. Okay, that is called, for those of us that don't watch football, an interception.
So,
And the intercept is like the root of the word.
Yeah, intercept. Right? Sean, it's a noun. Tyler?
Isn't it also in like radio frequencies where like you try to intercept the signal?
Exactly.
yeah, you can do that.
Yeah, if you've got a radio frequency, right, and you intercept the signal, you're like breaking it at a certain point. So here's Christian. There's the interception point, okay, between these two lines. So it's just wherever two lines cross, okay? That's basically what an interception is. That make sense?
Mr. Church, why does Christian have long arms?
Because he's got to jump up and catch the ball and intercept it. That's why. Okay?
Intersection on like a road where all there's like
Intersection, yes. Yeah, definitely. Same kind of thing, right? If you're at an intersection in the road, it's two roads crossing. Same idea. All right? So, you guys have learned about the y-intercept, yes? Right? The b value on an equation. Have you guys learned about the x-intercepts? Maybe, maybe not. Okay? So, an x-intercept is where a graph crosses, obviously, the x-axis. The y-intercept, as we all know, is where the line crosses the y-axis. Okay? We could have multiple y-intercepts and multiple x-intercepts for a function, depending on what the function looks like. Okay? So if I look at this crazy function right here, I'm going to zoom in as close as I can. If I'm looking at this crazy function right here, right? Here's my x-axis. Okay, I'm going to do it in pink. There's my x-axis. How many times does this squiggly line cross the x-axis?
3 times.
3 times. One right there, and once right there. All right, and these two endpoints are going to go on forever, so this is never going to cross the x-axis again. All right? So my x-intercepts, we could just write down here on the side, are at, where's this far left one at? Negative 1, 2, 3, 4. Negative 4, 0. Negative 2, 0. Where's that third one at? Alex?
0.3.
Sure, that's a good estimate. 0.33, comma 0. It looks like it's about 1/3 of the way over on the x-axis past my origin.
Are we going to use fractions in like these situations?
You could use decimals. It's probably better to use a decimal for this one. Okay, how many times does this line cross the y-axis? Here's my y. I'm going to do it in blue. There's my y-axis. How many times do we cross that axis?
1 time.
1 time. Right about there. Where would what would the coordinates of that point be? Any ideas? This blue point right here? Liana?
0, 5.
No.
Right here?
No, it's -3.
So here's the origin.
Negative.
Yeah, we're going down 3, so 0, -3.
Yeah, it's
I'm
-3.
sorry.
That's all right.
It's okay.
I appreciate you raising your hand. You guys okay in the back? Why is there not a pencil in your hand right now? Perfect. Okay. Pretty easy, right? Where does it cross both the lines? You guys have 2 highlighters in your material boxes, yes?
Yes.
Let's get them out. All right. So we got the intercepts down. The intercepts is the easy part. Now, a function can be both positive and negative at different intervals. So we know that a function is positive when its graph lies above the x-axis. Okay? So we got to think about this. Every time I cross the x-axis, I'm changing whether my function is positive or negative, right? Because if I cross it, I'm going from the bottom to the top, or I'm going from the top to the bottom. So at each one of these x-intercepts, I'm going to draw a vertical line. Now I can clearly see I've got 1, 2, 3, 4 separate intervals where my graph is going above and below the x-axis. Right? So for this first interval down here, okay, right here, is this above? I'm going to just do it in red. Is this little section of the graph above or below the x-axis? Below, right? So it starts at negative, what did we say that was? -4?
Yes.
And goes on forever in that direction, right? So we know that our graph is negative when x is less than -4. Okay, that's one interval in which this function is negative. What about this next interval? Are we above or below the x-axis here?
No.
Right here, this little curvy?
Oh.
We're above, so that's going to be positive. All right? So we know that my function is going to be positive when it's in between -4 and -2. So x has got to be greater than -4, but less than -2. I can't do anything right now. Okay. What about this little dip down section here? Is that above or below?
Below.
That's below. So there's another negative interval. Okay. This interval goes from -2 to 0.33. Right? So when x is greater than -2, but less than 1/3, I have a negative interval again. What about this last little bit up here?
Above.
It's above, so that's going to be positive. So when x is greater than 0.33. That was probably a more difficult example to start with than we needed to do. which is actually good because now all these other ones are going to look a lot easier. That's what I just said we were going to do.
Easiest solution.
All right? Let's look at this first example here. Okay? Where does this line cross the x-axis? My x-intercept.
3, 0.
Well, here's my x-axis. Okay, I cross right there. What would the coordinates of that point be?
No.
0, 3 is super close.
0. 3, 0.
3, 0. Here's my y-axis. Where do I cross my y? Bless you. Where does this line cross the y-axis? 0, 6. Thank you, Gurpreet. 0, comma 6. Again, there's the easy part. Right? Now again, at every x-intercept, I'm going to draw a what?
Line.
A vertical line. Right? Because again, if I'm crossing the y-axis, I'm changing my interval from positive to negative or from negative to positive. So to the left of this pink line I just made, is that a positive interval or a negative interval?
To the left of it?
This section right here, this to the left of that pink line, is that positive or negative?
Still positive. Because it's above the x line.
Positive is when it's above the x-axis. Is this line right here above or below the x-axis? Above, even though it's on the left side of my graph and it's going to the left and your brain tells you negative, negative, negative. This is a positive interval because it's above the x-axis. Okay? So what could I write for my positive interval? If I'm going to use an inequality, if I could write it as an inequality, what would it be? Well, it's going to be x. We know x is positive when it's less than 3. Right? Because when x is 2, it's positive. Or sorry, when x is 1. When x is 2, it's positive. When x is 1, it's positive. When x is negative 4, it's going to be positive. So any x value less than 3 is going to give me a positive interval on my function. What's up, Christine? Okay. See you later. So the only little section we have underneath the x-axis is this tiny arrow right here. Right? What inequality can we write for that interval?
X is greater than 3.
Perfect. X is greater than 3. Interesting. Give me a thumbs up if you're confused. It's okay. We're going to probably take 2 days on this, to be honest with you. We're not going to get to B0, whatever, 7 today. What part is confusing you? For those of you that put your thumbs up. Everything's not a good enough answer. Okay, the positives and the negatives. Is identifying the intercepts confusing? Okay, so that part's okay. When you have to write the inequality? Okay. How can we do this so that it makes more sense?
Wait, Mr. Church, isn't 0 positive?
Simplify.
What?
That's how me add this and subtract that. That's how I learned now.
The intercept that
You have to explain it to me. That's
Okay.
It's like I think okay.
Have it.
if 0, like after the x-axis of 0,
Just process.
I'm not understanding your question. You might answer your question in the next example.
Oh, I told you this yesterday.
less than or greater, less than or equal.
So, like I said, the question's not making sense. We'll come back to it, okay? Let's take a look at the second one.
She's nice.
If you guys know how to find the intercepts real quick. I've got one x-intercept, and I've got one y-intercept. Where are they at?
Oh, okay, then that makes more sense. Yeah.
Okay, can someone help me out? What's my x-intercept here? Chang Z. Negative 3, 0? Is close. Sorry, negative 2. I misheard you. Negative 2, 0. Here's my origin. We're at negative 2 on the x-axis. Boom. Is that my only x-intercept?
Yes.
Okay. Who can help me out? What is my y-intercept here? Aaron.
-6, 0.
Super close.
0,
There you go. 0, comma, negative 6.
The 6
Is there any other y-intercepts?
no.
No. Okay. Now's where we get confused, right?
Yeah.
Okay.
I think I got it.
Everybody have a ruler in your supply box? Take out a ruler.
We only have 3.
You can share. Sharing is caring.
Actually, I do have
I have rulers.
Why is everything? I used to want my brother with
from Willy Wonka. My mother used to say it.
Oh, we're twinning. I know what twinning.
All right. Let's try and make this less confusing, shall we? I only want to find my positive interval. A positive interval is above the x-axis. So what part of this graph am I going to cover up? The bottom. Okay. Now we are only looking in the positive section. Do you guys see that?
Yes.
See that little tiny arrow poking out?
Yeah.
Right? Is that arrow leaning to the left or to the right? To the left.
I don't know my left and right.
Yeah, I don't know my life.
I have to do, like, you have to do the L.
Right? This arrow's going towards the left.
So
Okay?
pause.
So it's going to smaller and smaller numbers. Larger negative numbers, smaller numbers, right? Where are we at on the x-axis here?
Negative
2.
Negative 2.
Right? I'm at negative 2. So if I had an x value of negative 5, would that be above the x-axis or below the x-axis?
Below.
If the line is going to the left forever,
Above.
like this, right? It's continuing on forever, right? So the only time this arrow is going to be above the x-axis is when my x-coordinate is less than negative 2. Okay, don't say anything. Just think about what I just said. Try and rationalize what's coming out of my mouth, okay? The only time this arrow will be above the x-axis, right, is when my x-coordinate is less than that negative 2. Think about it for a second. Don't say anything.
Wait, say what?
Oh, you're saying something. I'll say it one more time. Are you ready? Are you actually listening?
Yeah.
Okay. See how this arrow is above my x-axis,
Yes.
right? Negative 2 is the turning point. It's my intercept. It's where we change intervals, okay? Negative 2 is where we change. This line's going to the left. So any x value less than negative 2 is going to yield me a point on this line that is above the x-axis. Okay? No? It's kind of making more sense?
It makes sense.
Okay. I mean, I feel like that's as simple as I can put it. I'll try and think of another way to talk about it, but... So, if that kind of makes sense, let's see if we can figure out the inequality, right? So, x, right, has some relationship with negative 2. Okay?
Yeah.
If we want it to be positive, my x-coordinate has to be less than -2. Right? When my x is -4,
It's
right here, I'm still above the x-axis. When my x is -5, I'm still above. When it's -6, I'm still above. Just out of curiosity, give me a thumbs up if that makes sense. Thumbs sideways if it kind of makes sense. Thumbs down if it still doesn't make any sense at all. Okay.
Maybe.
Okay. One more time real quick. Up, down, sideways. How's it going?
kind of like here.
Okay. Perfect. Well, not perfect, but getting better. Okay, now I want to figure out my negative interval. What part of the graph am I going to cover up with my ruler now?
The y-axis. The y-axis. The bottom part. So you cover up the top.
I'm covering up the top. Okay?
So it's this part.
Now I'm just looking below the surface, right? I'm looking at my underneath. Okay, that's a lot of line. Because this is a straight line, -2 is still my turning point, all right? For every single point on this line here, right, if I told you to find the x-coordinate of any one of these points, would they be greater than -2 or less than -2?
Greater.
They'd be greater than, right? -2, -1, 0, 1, 2, 3, 4. This line's going to keep going, right? This point has an x-coordinate of 1. So x has to be greater than -2 in order to yield a negative interval of my line.
Okay.
Again, it's a lot easier for us to understand with a straight line because there's only one turning point, right? Right here at -2, I'm going to draw my pink line. That's where things start to change. Where here is my positive section. Here is my negative section.
What about the other side?
Is there any function on either of these squares?
No.
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 So we don't even talk about them at all. Right? My positive side, right, yellow to green, sure. My positive side is anything less than -2. Maybe this will help visually. My negative side is anything greater than -2. Again, we're focusing on the x-axis. Okay? So for this pink section of my function, every single one of these points has an x-coordinate further to the right than -2. Do you guys see what I'm talking about when I say that? For this yellow section up here, every single point I could draw on this line has an x-coordinate that is further to the left than -2, which means it's less than. We're going to start highlighting. Let's do that. Let's go back up to number 1.
We did the third one.
We're going to highlight this little, obviously we're going to do the third one.
We have 10 minutes.
Okay, my yellow is going to be above the x-axis. My pink is below. So if I look at number 3 is a little bit different. Is number 3 a straight line? No. All right. Who could help me out quickly? What are my x-intercepts here? Here's my x-axis. I've got a point there and a point there. What are my coordinates for those? Alex, help me out.
1, 0, and 4, 0.
Cool. I know that when I write my inequalities, there's going to be a 1 involved and there's going to be a 4 involved. Okay? I know when I write my inequalities, take a look. My x-intercept was -2. Both my inequalities had a -2. My x-intercept was 3. Both my inequalities had a 3. Even when my x-intercepts were something crazy, -4, -2, and 0.33, all of my inequalities involved a -4, a -2, and a 0.33. So whatever the x-intercepts are, that's going to help you understand what you're writing for your inequalities, okay? What's my y-intercept? I've only got one of them. 0, comma what?
-4.
-4. Okay? That has nothing to do with what we're talking about. The y-intercept. When we're writing our inequalities, it has nothing to do. Okay? Because our interval is above or below the x-axis. Okay? So at my turning points, which are these two pink dots, at these turning points, I'm going to make a vertical line through both of them. Boom. Boom.
Okay.
Now I'm only going to look at the positives. Okay, where is my function positive? On the left section, the middle section, or the right section?
Middle.
In the middle. See that little curved line right there?
Yes.
Okay, so this little section is where my function's positive. It's the only part of this function that's above the x-axis, right? And it's in between 1 and 4. I feel like visually this one makes a little bit more sense. Do you guys see that?
Yeah.
This little section of the function, we cut out everything else. I'm only looking at the yellow highlight.
Yep.
Is in between 1 and 4. So, x has to be less than 4 or greater than 1.
Yeah.
We're just sandwiching x in between my 1 and my 4.
Makes sense.
It's starting to make sense. That's good.
Okay. Now that
We'll take our time. We're not in a rush.
what does x have to be? Oh wait, no.
Okay, give me a thumbs up if you're with me so far on this one. Okay, Kai, Kaylee, Raven, Tyler. I'm going to look at the negative now. I'm going to cover up my top half. Where do we see this function appear? On the left section, the middle section, or the right section?
The left and
The left and the right. I'm going to highlight my left side.
Oh.
I'm going to highlight my right side. Okay, my function doesn't appear in that middle section, so I'm going to leave it alone. So, let's break this into two sections. If I'm looking just on the left, right, my turning point is at 1. Are these x values less than 1 or greater than 1 for this section right here? They're less than, right? Further to the left on the x, that's less than. So we know that this is going to be negative when x is less than 1. And, right, let's look at this other section. Are all these x values here less than 4 or greater than 4? Greater than. So let's take a look at this, right? When x is less than 1, that's this section right here, my function is negative, right? When x is in between 1 and 4, that's this yellow section, my function is positive. But when x is greater than 4, this section, my function is negative. So we start out negative, we cross, we go positive, we drop back down, cross again, negative. Are you guys highlighting yours too, like me? You should be. You should be.
I have a question.
Sure.
For the negative side, couldn't you also write it in a different way, like the positive, where you put the
Like this one?
one greater than
So what this statement is saying is that x has to be less than 1 and less than 4.
Oh.
So it's not 100% right. Partially right, but not 100% right. Because if x is less than 4, it could be positive if it's 3 or 2, right? That's why you have to write them as separate. We can only combine when it's like that. See how these are two separate? They gotta be two separate. They're Tyler?
Can I go ahead on this question?
Yeah,
Sure.
you could do that.
Yes. It's a free crunch.
Yeah,
All right, last one. Same thing but opposite. Here's my x-axis. I'm gonna make a dot right there and right there. What are my x-intercepts here? Yeah, Chengzi.
-4, 0.
Perfect.
And 3, 0.
Awesome. Great job. I know right away that I'm going to see a -4 and a 3 pop up in my inequalities. All right? What's my y-intercept?
-12.
Yeah, it's about -12. I could say -12. 0, -12. All right? I'm going to take my 2 turning points on my x-axis, my x-intercepts, and I'm going to draw vertical lines through them. Okay? And I'm just going to look on my positive. So what's above the x-axis? Left, right, or middle sections here?
Left and right.
Left and the right. Positive up here, positive up there. I don't see any function in the middle.
So we make it separate because it's okay.
If you feel a little bit more confident, give it a try on your own. See if you can come up with the inequalities, and then we'll talk about it. Well, I mean, I'm going to keep talking about it because we only have 3 minutes. I look at the bottom. I'm going to highlight my negative section here. Boom, 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 boom. Right? So I know it's positive when x is less than -4 and when x is greater than 3.
I think like wait.
And I know it's negative when x is in between -4 and 3. Okay, hopefully some of the puzzle pieces are starting to find their fits here with this. We're going to take our time. Obviously, don't do the homework tonight, please. Okay? Don't do the homework.
Can I do it?
What did I just say?
He just wants to get ahead. Not show off. Okay, show off.
He wants to show off.